The time is now 12 p.m. Central Time, and I'm your host, Dr. Matthew Richardson, and this is another session of CosmoQuest Astro Office Hours. And so my plan today is to kind of pick up where I left off in my previous stream, where I am attempting to fix some analysis code that I'm writing. But before I get into all of that, let me go ahead and first verify that I'm actually streaming live. So I'm going to go ahead and log into Twitch using my Chrome browser. And to do this, I'm going to remove a lot of the apps that I currently have open because I want to make things easier on my Pro laptop. Okay. All right. Let's see what we got. I think I'm streaming. I should be streaming. It's weird. It's not really showing. Oh, I'm live. It shows that I'm live. Perfect. All right. So hi to everyone that's here. Those people being. So let me do a quick call out of currently who's here. Hey Guido. This time around, I shouldn't have any funny business with popping out the chat because I've learned my lesson from last time. I will strictly use Chrome for Twitch and use Safari for everything else. All right. So, to quickly kind of like lay out what my plan is today, I'll start by first, and I've done this before in previous streams, describe exactly what the incidence angle analysis code does. Its overall objective is to be able to determine how incidence angle on the lunar surface, that is, how sunlight, how solar rays and the angle it makes with the surface affects how our users, how CosmoQuest users are marking craters on the lunar surface. And the way in which they're doing this is by annotating images that we have of the lunar surface taken by the Lunar Reconnaissance Orbiter. And the overall name of the project is called Moon Mappers. If you guys, if you're new to my stream and you have the time, go ahead and check us out, CosmoQuest.org, and we have currently active 5 projects, 4 of them being mapping projects where you're mapping craters, and one of them being the newest project, Image Detective, where the objective is to identify features as well as geolocate images taken of Earth by astronauts aboard the International Space Station. So, in my last stream, I was talking about the fact that my incidence angle analysis code is having some issues with how I'm defining the orientation of images to be able to make the code work properly. And so we had a really good discussion. Keeper of Maps, I don't know if he's here currently. And I kind of I didn't miss my chance, but I kind of didn't get out to actually saying hi to everyone. So, hey Guido, hey Fajuent. Oh, this is a new name, and I hope I pronounced it correctly. Hi G Gono. Hi Lammy Hop. Hi Michael. Hi Peter. Hi R Instro. And hi Truck Captain Stumpy. Guys, welcome to the stream. But yeah, Keeper of Maps was like kind of like taking me to school on how I should be viewing um, how the Lunar Reconnaissance Orbiter is orbiting the moon, and how it could be taking images. That is how the camera aboard the satellite is oriented, and it was all very, very, very helpful information. Um, and so what I ended up doing ultimately was going through every single image that we currently have in our database for users to annotate. And I took those images and I've compared them to the images that are stored on the Lunar Reconnaissance Orbiter's online image archive. And I did this to be able to determine exactly what the orientation of the images is. And so what I was able to determine is that the orientation of the images are not all the same. That is to say that if you were to take two of the images stored in our database for this particular, for the Moon Mapper application, and you were to compare them, you would notice that for some of the images, how the way in which we define the top edge of an image isn't the same way in which we define the top edge of another image. That is, if you were to say that one image, the top edge points towards the north, that might not necessarily be the case for a second image, as its top edge might point towards lunar south. So and so I realized once I saw that it was going to make my job a little bit more harder in being able to correct the orientation. However, I mean, hard isn't the problem. It's more so just getting it done, right? So my plan for today is to kind of, and the only solution I've been able to come up with so far, it's probably not the most elegant solution I can come up with, but it should work in theory. The objective is to basically construct a file that I can use as an input to my incidence angle algorithm that will tell the algorithm how each image is oriented. And right now, that's the only way I can think of doing this. What you kind of see in the background is my typical setup for how I modify my incidence angle algorithm. That is, the top window underneath my face is showing a Emacs window. I think I'm using Aquamax actually to be able to make changes to my source code. And the bottom window is my terminal. I have 4 tabs open, 3 of which I'm using for the incidence angle analysis, and the very last tab, the 4th tab, is the MySQL database that we're using to store the data in. Alright, so let's go ahead and jump right into this. So I'm going to need to create a new window that will show the file that will tell my algorithm exactly how each image is oriented. So let's do that. That's the very first thing I should do, that I need to do actually. Alright, I'm going to open up my OBS software. And I'm going to, well, you know what, I currently pass one file to the incidence angle algorithm anyway. So I might as well just modify that file because I believe it already has information that's important and that I can just be able to use to be able to do this. Makes things easier versus passing 2 files to the algorithm. Alright, so let's first navigate to where that file is located, stored on my my hard drive. Of course, right now you guys can't see what I'm doing. I'm basically opening up a bunch of folders. I think this is an incidence angle analysis, and it might be stored in the bin directory. But you'll be able to see the file in just a second. Yep, here it is. All right. So the name of the file is LRO incidence angles, and of course this file is very important because it's the main file that I need to use to be able to know what the incidence angles of the images are. But I'm just going to add a few more columns that will allow me to be able to define how the images are oriented relative to the coordinate system that I've established. All right. So OBS needs to be able to see this. In fact, we're going to give this its own scene. So let's do this. I'm going to duplicate this scene. And let's just name it scene 1. So at the current moment, both scene 1 and scene 2 are showing the exact same thing if I switch back and forth between them. But I'm going to go ahead and add another window. It's window capture. And this is going to be input file. And here we go. Let's go ahead and increase this so it's nice and big. And I can actually get rid of everything else. The text editor for this is not needed. And the terminal for this is not needed. But I can always bring back my face. Alright, so this is the file I'm going to modify. And the reason why this file is perfectly set up already is that it already, along column 1, I'm already giving the image name. And so what I'm basically going to do is just add, I think four more columns will be needed to be able to define the orientation of the image. Alright, so I should probably also describe exactly how my algorithm is using the images, how it's currently defining the orientation of the images. But before I move on, let me go ahead and make sure I'm catching up with all the comments. So to answer Truck Captain Stumpy's question of the original database owner doesn't have a means to establish. So they actually have, so LRO, the Lunar Reconnaissance Orbiter collaboration, for lack of better words, I mean it's a NASA mission. So NASA employees have established, or at the very least, people who are associated with this mission, whether they be NASA employees or not, have established a means of indicating how the images are oriented. And the way in which they do it is they define the latitude and longitude of each corner of the image, allowing for that image's orientation to be known. However, in our database, which I can actually just quickly show, and it might even be up actually. So let's go ahead and switch. I'm gonna switch scenes. Oh, I love that. That's perfect. So I've switched scenes, and if you look in the bottom terminal, this is actually one of the images that I'm using for this analysis. So you'll notice, and I'm highlighting here, M10921569LE, where in general, everything before LE, I believe, corresponds to, of course, the image ID. However, the LE, I think, specifically corresponds to which camera aboard the Lunar Reconnaissance Orbiter is taking the image of the surface. I can't go into great details of all the cameras on the Lunar Reconnaissance Orbiter, but I do know that there is the NAC, which is short for the narrow angle camera, and there's the WAC, which is short for the wide angle camera. And the images that I'm using have been taken by the NAC, which is the narrow angle camera. That's the first part. The second part of this is that for each NAC image, there can be two different perspectives. So I think there's two different cameras for the NAC images, where one of the camera can correspond to what you might define to be the left camera, and the other camera can be what you define to be the right camera. And so for this particular image, I know that it has an image ID of M1092156991. And I already know that these are NAC images, and that this particular image comes from the left camera of the NAC system. for lack of better words. But the key thing here that I want to get to is the fact that if you look at columns 1, 2, 3, 4, 5, so columns 6 through 9, you will notice that we define in our database the minimum, maximum, and the minimum, maximum latitude and longitude respectively. And so this information is not enough actually to be able to define the orientation of the image, because you can use the minimum latitude and basically assign that to any side of the image. And so what I've done since my last stream is determine exactly which edge of the image corresponds to the minimum latitude, the maximum latitude, and so forth. All right. So yeah, exactly as your second statement is perfect. So they've put this information in the metadata. And the information I'm currently showing on the screen is the metadata we have for our images. Or at least for this one particular image. Hey, Keeper of Maps. So I think you may have missed my intro where I was telling everybody that you kind of took me to school as to how I should be thinking about this, thinking about the problem that I'm having here. And I think I've come up with a very simplistic solution. And the idea is to use the fact that I've compared the images that we have stored in our database relative to the images that are stored in the Lunar Reconnaissance Orbiter's online image archive. So I've used those sets of images and determined the orientation of the images that are stored in our database. And my plan now is to modify the one single input file that I pass to my incidence angle analysis code to be able to define what the orientation of those images should be versus the orientation that I've kind of imposed incorrectly. Sorry, Peter. Apparently, when you were trying to say hi to someone, the auto mod basically was blocking your message. But don't worry, it's there now. I wonder because NASA should have an automated method to sort. Yeah, they do. They do. So, Keeper of Maps corner. Yeah, no, you're right. You're right. It doesn't matter. It doesn't matter the Well, let me not say that actually. So, from my understanding, the reason why we've reoriented the images in the first place is to ensure that shadows within the images would all be from the same side, so that we can at least remove how shadows may affect how our users are annotating the images. Nevertheless, though, incidence angle though is something that we really can't control, right? You can't control how solar sunlight hits the lunar surface when an image is taken. I mean, you could remove those images from you could make those images not available for the users to see, but it's interesting to be able to see if indeed incidence angle does affect how our users are annotating the images. That is, marking craters. So the corner was a reference to how the Lunar Reconnaissance Orbiter's website indicates the orientation of the images. They define the latitude and longitude of each corner of the image. Whereas in our database, this based off of the information we currently have, there's no way to be able to define the orientation. But we ourselves know the orientation, though. Well, the reason why it's important for my algorithm to be able to know how the images are oriented. That way I can be able to compare craters to one another. Which I'm going to probably have to talk a little bit further about too, now that I think about it. Yes, you're right. Our database holds a bounding box. However, we don't know exactly how that bounding box is flipped. Well, at least based off of the information in our database, you wouldn't know how the bounding box is flipped. But we ourselves know it. Luke is not the last Jedi. I saw that movie and it was pretty good. I liked it. Um, but before I get off track here, let me go ahead and continue doing what I was doing before. So I'm going to go ahead and switch scenes back to the file that I wish to modify. All right. And so this is the one and only file that I currently pass the algorithm. As you can tell, it provides the master image name in the left-hand column. And in the second column, it provides the incidence angle, which is probably the most important information that's being passed to the algorithm. The most important information that's needed for me to conduct this analysis. And so now I'm going to add 4 more columns that will allow me to define the orientation of the images for my algorithm. Yeah, we definitely could grab more information from Elrock's database, and I mean, it might be good. I'm unsure at the current moment. It actually might be good at the very least to add the incidence angles, incidence angle column for each master image, given that we're now doing this analysis. In the event someone in the future wants to, try to reproduce our results, they can have this information readily available to them. Versus doing what I did, which was take each image in our database and then go manually grab the incidence angles myself. What's up, Big J? How's it going, man? All right, cool. Yeah, so I mean, this is a little bit off topic, but so me and Joe would like to start doing co-hosting on these streams. I think it'd be pretty cool. We did it during the conference this past last week. That is exactly right, Keeper of Maps. So I was actually talking about that a little bit earlier. So these are all NAC images, and apparently for the NAC, I don't know if this is also true for the other camera that's on the Lunar Reconnaissance Orbiter called the WAC. WAC standing for wide angle camera. These are all NAC images, which corresponds to the narrow angle camera. And apparently for this particular camera system, it has, I think, 2 cameras. And as you already state in your last comment, that the reason why certain images have pairs is because it corresponds to a left and right camera. Perfect. But yeah, guys, I also want to state this before I continue, and that is that, I love being a part of the weekly space hangout community because it's composed of a lot of people that have a lot of different, skill sets. And I will truly say the Keeper of Maps was living up to his name and how he was explaining everything to me over the past few days. Actually, I mean, even before then. So again, Keeper of Maps, thank you. I mean, because honestly, I knew nothing about the stuff that you were talking about prior to you actually explaining it to me. Because my background is not, I've never even touched it before. Alright, so let's go ahead and do this. 4 more columns. So the way in which craters need to be able to be located in the coordinate system I've identified is that the upper left-hand corner of each master image must be known. Now note, I'm saying master image because in our database we have the master images, then the next step down from there, next level, we have the sliced images, which are basically slices of the master image, which are the actual images that our users are actually marking, annotating. And then the next step down from there, of course, would be the craters within each sliced image. And so the way in which we can identify the positions of our craters is that each crater, and I want to make sure I explain this correctly, each crater references the upper left-hand corner of each sliced image as its own personal origin. So each crater within a sliced image knows where the upper left-hand corner is at. Okay? Each sliced image that comes from a master image knows where the upper left-hand corner is of that master image. And so now we can move to the wide scale of things, which is I've established a coordinate system in which each master image, just left-hand corner, knows where the origin is of the coordinate system I've established. So yes. So that's actually a key thing here. So Keeper of Maps brings up an actually very good point. The images that we're using from the Lunar Reconnaissance Orbiter do have overlap. In fact, we need for them to have overlap because in order for me to do this analysis, we want to know for a given region that's been imaged at two different incidence angles, how does the fact that we've imaged this region at two different incidence angles that have been marked by users, how does the fact that the incidence angle has changed affect how the users mark the images? It's kind of like if I give you an image of, and I'm just going to make something up. It's kind of like if I give you an image of Washington, D.C., and I ask, let's say I take the image like at noon, and I ask a bunch of people to identify, major structures or, landmarks in Washington, D.C. from an image taken at noon. I mean, they'll go ahead and do it. Good. But then what happens if I give the exact same image, but now I've changed the lighting somehow? Maybe I've changed the lighting somehow. Maybe I've taken the image at midnight and there's very little lights. And I ask, okay, now mark, the features in the image. We're kind of doing the exact same thing here with the incidence angle analysis and these lunar images that we have, where the incidence angle has changed. And so we do need for the images to be able to overlap, and there is overlap between the images. Well, I'm looking forward to the cosmic ray questions. Wait, rename this to. I'm reading Truck Captain Stumpy's statement. Rename this to Scientific MJLET. The double. Hi, Larry. I'm sorry. I missed saying hi to you earlier. Man, Peter, you're bringing up some really good side conversation. It really wants me like to move away from what I'm talking about to start talking about Justice League and stuff like that. I'm really looking forward to seeing, and this is not the same universe, of course, but I'm looking forward to seeing the Black Panther in February. But let's see, catching up with comments here. Well, yeah. So if the master images overlap, yes, then the CQ our slices also overlap too. All right, Keeper of Maps. Thanks for stopping by. Talk to you later, though. So let's see. Oh God. Okay, let me stop. Let me get back on topic. Peter, I'm definitely going to talk to you about this on Slack. I mean, Marvel comes out with some pretty good movies. All right. So again, let's go back to actually adding these 4 columns. All right. So upper left-hand corner. So I would like to know what information. Let's go ahead and state that we want to know left longitude, maybe. So upper left longitude. So I'll put upper left longitude. Then of course upper left, excuse me, latitude. Another column that will be important. Let's make sure I'm tabbing the stuff. That's cool. All right. The next thing I would want to know is I need to know how the latitude and longitude change as you move away from the upper left corner. So let's say moving, of course you can only move right if you're at the upper left, so moving right. Let's expand that because all right, I've modified the physical. All right, I don't like the fact that I'm running out of room here. So I'm just going to shorten this to U upper left longitude and UL latitude. I can tell that my face is blocking stuff, so I'm going to move the image of my face down to the bottom right. I'm sorry. I'm going to take another little quick break here. That's insane. I agree with Big J. Out of 300 seats, only 20 people? Ouch. All right. Let's get back to editing this document here. All right. So moving right, and of course moving down because I'm at the upper left corner. And at some point, I'm more than likely going to change this, but the naming system that I'm using here, but this will have to work for now. And so to do this, I don't actually want to put physical values because I have the physical values of each of these corners. So I'm just going to quickly show you guys that I really did go old school with this, and I have like a stack of papers here, and I'll just show you one of them. And hopefully you can see what I've done here. So let me pull up my screen. Hopefully the resolution is good enough. But basically, I went through each image, and what I'm kind of showing here is the fact that I've taken the original image, made a little rectangle for it, and I've defined which edge corresponds to what. That is, in this case, the top edge corresponds to the maximum latitude, bottom edge corresponds to the minimum latitude in this case, and then of course there's the left and right edge and how they correspond to the maximum longitude. And that's for the original image that I'm looking at on the online database, online image archive for the Lunar Reconnaissance Orbiter. But underneath that, I've taken the same image in our database, and I've basically defined the same corners, but how they may have changed. And so I honestly don't need to actually specify physical values because we already have the physical values in our MySQL database. All I have to specify is whether or not the upper left-hand corner corresponds to the maximum or minimum latitude, and also the maximum or minimum longitude. So I can actually do that for each image. So I'm actually going to look through the set of images I have here, and I think I already have them in the proper order. So let's see. Upper left-hand longitude should be for this particular image, should be the maximum value. So I'm just going to put max here. Upper left-hand latitude should be the min. And as I move from left to right in the image, the values decrease because I'm moving from maximum to minimum. But you know what? I wonder, actually. That particular information really isn't needed, right? Because if I'm already specifying that the upper left-hand corner's longitude is the maximum, that would automatically have to imply that the upper right-hand corner's longitude, or basically the right-hand side of the image, has to be the minimum. And you can use the same logic for the latitude, moving from the top edge to the bottom edge. So I can actually remove these two columns. I don't need them. This will cut down on the amount of information I need to actually. This will cut down on the amount of information I actually need to put into the algorithm. All right. So then the next one from here. And I can actually just go through all of this and just put this stuff in. This is going to be min. This is also going to be min. Done with that page. For this one, it's going to be min, or max, excuse me. And this is going to be min. And yes, this is the tedious work at times that scientists must do. When I first started off, this is all I was doing. I wasn't doing any coding. I was just inputting information into a spreadsheet or something. Let's see. This one is upper left hand. This is min, max. This one's going to be min. This is also max. And you'll notice that there's no actual there's no trend here, right? At least there's no visible trend of what I'm showing here. If I added more information, more columns, then you might be able to see a trend, but at the current moment there's no trend. More columns of information, that is. Sorry, just give me 1 second, just making sure that I've done this correctly. Yep, alright. Get rid of that sheet, move to the next one. It is killing me that I'm not in on this conversation right now. Yes. Data set inconsistencies. The thing about it is that the information in our data set in our database is not. It's not that it's wrong. It's just that it's missing information that's vital. So if someone else were to look at our data set and try to like use it for what I'm doing now, they wouldn't be able to just readily do it. They would have to go grab information from elsewhere first. But it happens. It happens. Um, but you said you were in grad school, Lemmy Hop. What did you go to grad school for? If you don't mind me asking, that is. You don't have to answer, of course. Let's see. So 113. This is going to be max. Oh man, I was actually watching. It was an Isaac Asimov debate about. I think basically selling water, or not selling water, but obtaining water from the universe. That is like going to various worlds outside of our own, like going to asteroids or going to some other planet or some other moon in our solar system, and basically gaining water from those objects. And I think this is all due to the fact that we're running out of that precious resource on our own planet. And some numbers were thrown around, and I mean when they said these numbers, I was like, "Are you serious?" And I mean you can of course correct me on this because I don't remember the numbers exactly, but I think it was somewhere around like 2.5% of all the water on the world is actually drinkable. And of that 2.5%, a very, very, very small percentage is actually being used. It's actual like drinking water, water we use on a daily basis. Yes, Asimov is great. I started reading one of his books recently. So 2.5% is generous. Okay. Now, of course, I mean when they were saying this, I think they were saying like some of it, of course, is like in ice caps and stuff like that. It's water that's not readily accessible, but there's a very small percentage of that 2.5% that we actually use um, on a daily basis. Very, very small percent. Very small. It was ridiculous. Well, it wasn't that ridiculous. It was a small percentage though. And to think of the fact that one day we might be without water to drink here on Earth. That's kind of scary. Of course, it's not going to happen within our lifetime. More than likely, yeah, well, it shouldn't at least. But oh, that kind of kills me. Microplastic fibers in our water. I'm drinking plastic. That's scary. Oh wow, that's interesting. I'm responding to Big J's comment about the fact. Well, I don't. Where did you get this information from, Big J? If you don't mind me asking, because that means, I mean, the person who could do that, or the organization that could go into space and grab an asteroid and park it somewhere nearby Earth and just be able to say, "Hey, I got water. It's for sale. I'm selling it for like $1,000 an ounce. If you want it, come talk to me." That's why you drink coffee. All right, let me get back to this. Yeah, I can quite easily be distracted from what I'm currently doing. All right, let's see. Max, min. Oops, undo. There we go. Oh, okay. I see what you're saying. Yeah, yeah. I mean, such an endeavor. Even if you could find, an object that had that much water content in it, yeah, would be very difficult. I'd imagine. Um, is it? That's another interesting question. Cleaning up the current water that we have and putting programs into place to be able to do this. Yeah, I would imagine. Yeah, exactly what Susie's saying. If we plan to explore the rest of the of our solar system, I mean, we need to, of course, be able to make sure that the people that are exploring it would have water, of course, and they would be cut off from any sort of water supply here on Earth. So yeah, mining asteroids, um, probably even grabbing some comets. I've heard that that might be difficult because of the fact that comets are kind of fragile, at least for this type of endeavor. And so, in the process of you trying to actually like tow a comet, you might end up breaking it apart. Oh, Peter, don't get me thinking about drinking someone else's urine. That's we probably are. It's a possibility that in fact, yeah, I am Hop. Could you enlighten us on whether or not we're drinking someone else's urine? That's that's a scary thought. But I think we probably are drinking other people's urine. Of course, it's been cleaned. The water's been cleaned, But you know that I'm nowhere near ready to drink any sort of whiskey. Oh man, I haven't had a drink since the age of 22. I think that's how old I was when I said no to drinking any sort of alcoholic beverage anymore. I am so happy to hear that, Susie. Well, but nevertheless, now that Peter's brought it up. I mean, it's kind of hard to think of the fact that at one point the water that we're drinking had some other chemical in it that was not water. So yeah, in that aspect, I guess we are like astronauts. Oh man, they I've heard about that. Let's see. Is this the right one? 450? Yes, it is. So this is min, this is max. The next one should also be min and max. So there is kind of a trend here. So for image pairs, the upper left hand corner, latitude and longitude, will have the same it will have the same general value actually. So basically, you'd expect for a pair that whatever I define for the longitude and latitude, that is, if I define it to be maximum or minimum, that particular information should be the same for a pair of images. So that's one trend I am seeing here. Oh, Larry. That is bad. See flakes of toilet paper? Me personally, I couldn't live there for long. Is that the case today? If I were to go to Grand Prairie, Texas, or anywhere nearby and get some water, would I have to fear about drinking down toilet paper? It killed houseplants. Oh God, that's so. At first, I was trying to extrapolate some sort of like trend or pattern because I wanted to be able to modify my program in such a way that it's efficient while it's also, well, yeah, it's an efficient modification. Takes very little time to do the modification, and it's easy to understand. But I couldn't find any sort of trend, and I did speak with Pamela about it, and she told me that there is a trend, but that would require me to bring in, I believe, outside information. And so what I'm trying to do is just use the information that's currently stored in our database while bringing in very little outside information as possible. Honestly, the only outside information that I'm really bringing in is the information I'm showing in this file, because this information is not readily available in our database. We don't have the incidence angles in our database. I got this from the Lunar Reconnaissance Orbiter's online website or image archive. And as far as defining what the upper left hand corner should be, I've done this by comparing the images that we currently have to the images that are stored on the image archive. So I'm not having it match the LRO orientation. I'm basically just defining the orientation that we've imposed, the correct orientation, that is. At the current moment, I define all the images to have the same orientation. That is, the upper left hand corner, latitude and longitude should be the maximum values. However, as you see here, though, in the third and fourth column, the upper left hand longitude and the upper left hand latitude doesn't always have to be the maximum value that we have stored in our database. So yeah, the current way I've defined it, these two columns will basically show all max. However, in truth, it shouldn't be that way. It should be what I'm showing here, or what I'm inputting into this file. But yeah, this information is needed though. There's no way of getting around it. It's the only way I can be able to correctly define the locations of the craters. And there's also stuff with that as well, but I've already fixed that. And the stuff that the major issues with that was that in our database, the master images positions, for lack of better words, the bounding box. That's actually the best way of putting it, as Keeper of Maps stated earlier. The bounding box for each image is defined in latitude and longitude coordinate space. However, the image slices and the craters are all defined in pixel space. So I had to do some conversions there as well. But that wasn't too bad though. Yeah, so and I can kind of actually show you this here. So I'm going to go ahead and switch scenes. So let's do this. There we go. And so as you can see here, this is a master image, and the way in which I can determine the location of the bounding box is based off of the minimum latitude, maximum latitude, minimum longitude, and the maximum longitude values. However, if I were to go to one of its image slices that we have in our database, and I'll quickly pull that up. And so that information is being stored in the images table. What do I want? Where I think it should be image ID equals 3. I'm going to go ahead and just limit it to 1. Alright, it's not image ID. Then what is it? Let's quickly do this. Describe images. Oh, image set ID. Sorry. And so if you look here, and the information that I'm grabbing is from the details. I'm going to go ahead and highlight this. As far as being able to define its physical position relative to the master image, it does so in pixel space. You'll notice that it says X basically has a value, and it's talking about the upper left-hand corner of the sliced image. X has a value of 2,425. That's in pixels, and the pixel coordinate that is, and the Y pixel coordinate is 0. And of course, it gives the width of the image and the height. So what I've done is I've actually kind of like settled in the middle. So I've mapped the latitude and longitude coordinate system to a Cartesian coordinate system, where the unit is in terms of meters. And the way in which I've done that is I've used the what is that? The arc length formula. So given So guys, it's now 1 o'clock p.m. and honestly, the any bit of basically what I'm getting at is that I'm just going to basically be putting in values into this table, and that's not anything very interesting. But the discussion that we've had so far has been great, actually. But I'm going to go ahead and sign off now, and catch you guys all later at Astronomy Cast. Again, thank you for coming by to see today's stream. And as always, I hope that you guys had a great time, seeing me talk about the science. Well, what bit of science I had to talk about, and also other things as well. So I will see you guys later. Like I said, at astronomy class, and hopefully you guys can catch my next stream next Wednesday at noon Central Time. All right, guys. Bye. Filter tap on.